So hi, just let you trickle in the last of you and then introduce myself. I'm Martin Vestergaard, Technical Art Director at Unity in Copenhagen on the Sample teams. So 2 years ago, I was hired in to start building a team together with Peter Andreasen, who you saw present the FPS Sample at the keynote yesterday. Our goal was to build a team, a fairly lean team, to make sample games for Unity and provide, we call it, good practices, not best practices, because that seems arrogant and wrong, but we provide best practices to how to solve problems and game making. And we do that by creating vertical slices, you could call them, of games. So a thin slice, in this case, a single level, a few characters and weapons and so forth, all running together in a fully built game world with finished animation systems and so forth. Our team currently looks like this. So one pure animator, and I mean that in the most sort of creative sense, so he's a pure animator, and one technical animator who is essentially a programmer. He codes the IK, maintains the whole technical setup for all animation. And we have two programmers, Peter, the lead, and Mogens, our gameplay programmer, who sets up all the game systems, weapons, game mechanics, menus, etc. We have an environment artist, Janus, on the team, who also built the megacity that you might have seen. And we have me, a technical art director, but I'm kind of octopusing it a bit. So I'm also the art lead and the tech artist and the VFX artist and all kinds of things. So everyone is kind of touching many parts of the problems, but we're a fairly small team trying to stay relevant to mid-sized developers and small developers so that we don't go out of scope and go full AAA ape shit on everything, even if we do all have, and almost all of us has a AAA background. Practically the whole team are former Hitman devs, so I spent the last decade before joining Unity being an environment art lead and technical art director on the last two Hitman games, and co-developing the engine in-house that we used for that. So that's a little bit about where I come from. We use contractors for concept art and sound and art in general. So there are more people than this that went into building this, and they should have a huge shout out here because they did an awesome job. So these are 5 of the grumpy old men that sit and whinge about Unity in a dark room in Copenhagen all day, because we're developing this like you are developing things, and we moan as much about the engine as anyone using any game engine would moan about a game engine. So here's some early exploratory concept art of the game. So I had this conceptual idea because this was going to be a multiplayer team-based shooter. We had decided on that was a good representation of the FPS genre as it was as its core. And we needed kind of a dynamic for that setup. So 2 teams that don't like each other, that should shoot each other in the face. So we came up with this idea of basically a crash-landed terraforming ship that crash-landed into this sort of industrial base that was run by these robot automatons. So that would set up a nice conflict. It was basically, mechanics and industrialism versus the sprawl of this life that was spreading from the terraforming ship. This was one of our initial sort of exploratory key arts done by Mood Visuals, a concept house in Copenhagen. Check them out, they do amazing work. They worked on the latest God of War, really super cool shit for that game. And then we had Mario, a little bit more sort of, happy concept style here, who did these things for our main character. So really what we ended up with was kind of fusing these 2 inspiration sources. So we ended up with something that was more PBR, more realism, more gritty than this, but not as full-on realism as the initial key art. So we just explored until we had felt like we had an idea about kind of what space we wanted the setting to be in. So this is how the game looks now. This is the terraformer character on the left and the robot on the right, in a fairly happy, colorful setting, but with more advanced material usage than the previous concept might have implied. And there's cool stuff going on here, like subsurface scattering and layered materials and tessellation on the terrain, which is not terrain, but just measures tessellation on the ground. So yeah, so our goals at the team is to, as I touched upon, internalize user pain by dogfooding the technology pre-release at scale. So basically, we crash Unity so you don't have to. We want to inform future development of Unity based on this, and we want to bootstrap our users for success by releasing finished, polished products that you can take what you want from or completely use as a template to ship a game on. We don't really care. You get full free use of anything that's included. So every asset you can ship commercially should you wish to. If you forget to replace an animation or anything in the game, it's totally fine. Everything is in there for you to use in products built in Unity. The only sort of slight legal thing there is. You can only use it for Unity-based development. So our sample game constraints are no asset store, because then we wouldn't be able to share what we make freely with you guys. Vanilla Unity XE, but fairly bleeding edge, so you know the beta that is about to come out if it hasn't. No hacks. That's a total lie. We have some hacks. So this is what we strive for, right? But we need carryover solutions when we get stuck, and sometimes there's a delay until we get a solution back from R&D, and you know, so we do hack, but we try to keep it to an absolute minimum. So, as I've said, it's a fully functional multiplayer FPS game project that you can use for education, inspiration, or project bootstrapping. It's a vertical slice. It has 2 characters, a weapon, 1 basic test arena, which is like a white box level that we made a little pretty looking, and then 1 full assault mode game level where you have 3 bases you can capture, and there's a full and finished game loop for winning that level. We have robust server and client netcode, as Peter demonstrates in a separate talk today. And we're built on the new HD render pipeline. So I have a video here. Let's try if that works. So it's just a little, what the hell? Yep, there. So I didn't have time to do better footage, but this is just a quick introduction. So that's roughly how it plays out at the moment. And here is the actual editor. Let's just go back to presentation mode. There we go. So, like I mentioned, it's built on the high-definition render pipeline. A scriptable render pipeline, so it's one of the pre-built pipelines that we ship with Unity now in the SRP architecture. We also have the lightweight pipeline and a XR/VR pipeline. The main things to say about it is it's targeted at high-end devices, so DX11, DX12, Vulkan, Xbox, PS4, and Metal on Mac. And it's a unified sort of lighting renderer. So all materials, be they opaque or transparent or volumetric, light in a unified way. So we have full stack lighting basically on all material types. And they all work with GI. It's still in preview. We plan to be out of preview sometime next year. But I would say, out of many things in Unity that are in preview, this is one of the things that are in a fairly robust space. There are some corners of it that are a bit unexplored and a bit unoptimized, but everything is made in a modular way where you can go into the HDRP asset and disable parts that are still maybe more experimental than others. But all the base lighting, all the core sort of material features and post fillers and everything like that is in a very robust state. So prefab variants for production. I'm going to talk a little bit about production, one, because it's something that I spend a lot of time doing, and also because this is something that has changed quite dramatically from me as an art planner on games and samples like this with the nested prefab system that we recently shipped. So variants are basically a version of the old model prefab that we know it, but where you can add all the stuff that you would add to a typical prefab. So you can expand it and grow it while keeping the full inheritance of the prefab that you're piping into it, or the FBX that you're piping into it. So in that sense, you can plan out your mock-ups and your LED meshes, or anything you really want, you can plan out in Greybox, and as that FBX updates, it'll get pulled automatically, whether things disappear or reappear or etc. They will get pulled into the variant. So from a production point of view, you have a very stable base of getting art assets into the game, where you don't need to necessarily touch the prefab every time the model changes its layout or material assignments, etc. And this makes it a lot easier to plan out all the stuff you want to build, and then build it in parallel quickly without breaking the project at the end. So for me, a lead on a project where I have to set everything up and then maybe give it to an outsourcing studio or an external contractor, it really gives me a way to provide a robust template and just have them finish the art assets and have them come in without them breaking the game. So yeah, you get the full power of the prefab in variants with the robustness and flexibility of the old FBX model prefab. That was this kind of pseudo prefab before. So yeah, we can easily add, split, or remove elements from it without setting up the prefab anew. So when we initially start a mock-up, it looks something like this, sort of fairly naive, quite ugly, but it's still fairly detailed and it has a gameplay representative shape. So this is a furnace from a middle part of the level that we just saw. The documentation work on it is typically fairly elaborate, so I write out a lot of stuff. Exact triangle counts that I think this can be done with, and I map out like what maps I want to use in the material, what sizes they're going to be, etc. I feed all this stuff into Excel, so I know exactly what the memory footprint of this thing is going to be, and I know exactly how I'm going to name all the materials and models, etc., that are related to this. So I have the entire object being performance representative. I assign the correct shader to the material and stuff like that. I just don't do any work on it as such. And then I do sort of rough concepting on how I want it to look and say, follow the art direction of our key art, basically. So this sounds like a lot of work, but the benefit of mapping all this out is that you know, before you build anything, the exact performance of what you're going to get back. You can run around your level, you can figure out whether you can actually afford all the stuff that you've put in there. So, and when I do these, I put some buffer in there so I can kind of, be positively surprised by final performance instead of being sort of horrified by how the level runs when everything is done. So for the sample game, we utilized texture streaming, so it wasn't particularly important to be completely on point with my texture sizes, but that might differ depending on your project. So everything is MIP streaming here, so if an area is slightly dense in textures, everything just goes slightly lower resolution, so it's not a big deal. Then once that is documented and I feel confident that I know what I want to build, then we detail the gray box to something that is quite representative of the final try count. And then that's in the level, meaning that if you're a level designer or an audio guy, you're starting to have a pretty good idea of how to set up everything around this, and you know that really nothing is going to move when the final art comes back. So you can do all your, if you have cover planes, if you're a cover-based shooter, or if you're a lighting artist, you shouldn't be afraid if I put a light here, will it end up inside the geometry when the geometry comes back, etc. This is all about parallelizing production so that everyone in the team feels confident they have a safe space to work in before the art is done. So, and the more you can parallelize, the more everyone can work in conjunction, the cheaper it is to get things done. And no one likes redoing stuff anyways, right? That's no fun. So yeah, pretty much talked about this. Parallelized production, sound, level design, lighting can start working earlier. than if using a waterfall production method. You can hire contractors and outsourcing studios in a short and effective budgetable time frame because you know exactly what you're going to get back pretty much. So we stay a lot of, for a long time in this green phase, and we did something very similar on Hitman. So we only keep people on the team that can work in the green phase, basically, right? And then we contract in the other phase. So we can be super agile. We don't have anything to lose. The asset is not done. It doesn't carry any cost to it. If you kick it out of the game because there's no memory for it or you can't fit it on disk or whatever your limitation might be, it doesn't really hurt anyone. And we can draw all the data out of this green part of it to give to producers or people that budget and stuff like that to give them some kind of, you know, so they can sleep at night as well. So yeah, the key things are the whole green phase requires fairly low manpower. It's very agile, and you have height control. That doesn't mean anything, Martin. Okay. High levels of control is what I think I meant. So yeah, so here we have the room with the furnace in it in its earliest mock-up phase. We draw on top of it, and you know, this is production concepting. This is not the kind of stuff you see on ArtStation. This is just to get shit done. So because we have you know, a few pieces of key art that people can relate to, so we shouldn't need to finish every concept, right? We just want to give an idea of what are the kind of detailing we want to see on this thing. And then we end up with something like this in game. So hopefully it feels like it's a natural continuation of the steps you just saw. A few other examples on crash side, or really rushed paint over of it, and then final in game. So let me dive in a bit into some of the HDRP features that we're using. So we have subsurface scattering, layered materials, volumes and volumetrics, decals, and refraction and distortion. There are more features in HDRP, but these are some of the ones we're using. There's also iridescence and all other fancy stuff. We don't have a particularly strong use for that in this game. So for subsurface scattering and transmission, these are based off what is called diffusion profiles that you select in the shader. HDRP supports 16 diffusion profiles per project, and this means that you are limited to 16 different kinds of subsurface scattering. So one might be green foliage, one might be skin, one might be, in our case, this honeycomb thing that the terraformer has, this sort of like a yellow translucent material you see on the top of her helmet. And you can see like how the light is sort of nicely scattering in it on her leg here as it hits the outer rim. So authoring a diffusion profile is fairly intuitive in the sense that you have this interface where you can see basically a transmittance scattering preview. And the way you should think about this is like if I had the material in a dark room and I shone a bright white laser at it, how would the material look? So that's kind of how you can relate to this visual here. And then you can adjust things like the index of refraction and things like that. If I do that on something like my little berry here, which is using the transmission and the scattering, you know, if I go high index of refraction, I'll see a lot of specular reflection in the surface of it. If I go low index of refraction on it, I will see almost no specular reflection on the surface because it's all passing straight through the medium. There's a thin and a thick profile. The thin profile is primarily for things like alpha card foliage and stuff like that, to simulate that. And the thick profile is for things like the berry where you have a fully modular volume, or for skin for characters. Quick on-off. So you can see it's used on the vines and on the whole plant itself. So if you look at the green parts, they are quite harsh in their lighting before. And after, everything is kind of softened out and have a much more waxy feel to it. It's nice. And Peter said in the keynote, it looks kind of like you can eat the berry in this version, and in this version, the berry doesn't actually look that tasty. Layered materials. So HDRP comes with a bunch of pre-configured shaders. Some of them are called just lit, and some of them are called layered lit. So the layered lit version supports referencing 4 base materials. So a base material, and then 3 materials in red, green, and blue here, that are masked in either via vertex colors or via a mask map. On the sample game, the interiors, mostly the interiors of the entire sort of industrial base that we have in the level, are pretty much textured with these 4 base materials. So like a white paint, base steel material, this sort of bubbly heavy rust, and then a dirt texture. So these are not like super exciting materials, but they are also not meant to have, you know, that many unique features. They're highly tileable, highly repeatable, you know, base materials. There we go. So this is the sort of the raw bake of the furnace that we looked at earlier, with the steel material applied on top. So you can see there is some variation in the steel material. It's not a completely boring steel material. We do still put some custom stuff in there. But that's how it looks with a single material. Then we add the paint layer. So yeah, just for some color to pop inside the room. And then the rust layer, which is this bubbly rust texture we looked at before. And then the final dirt layer, which is this is the future. I can't stand 2 meters away from a machine and push on a button. And then in final in-game context here. So while, you know, the layered materials, it's not like we put a massive amount of polish into them in terms of like, you know, doing the blends to be super perfect, but once you're in there and you have lighting and everything else on top, it's kind of a good compromise, because the ability to tile these very detailed materials on top of it means you have a good compromise between the size of this asset and the textile density on it. You can hide some of the fact that your normal base map for the object is maybe not that high fidelity, and you model the whole object in a kind of a, you know, like it's made of rubber or something like that. It's a bit, you know, bulgy and soft and whatever, and then you add the high frequency detail with the base maps after, and you can get pretty high textile density, as you might also see on the lights down on the pillars and stuff like that. They're also all using the same materials for the layered blend and a fairly low-res base normal map for the actual asset. HDRP also has a concept called volumes, which is fairly new to Unity. So it's a way to partition your level and blend settings between those partitions. It's been used in the post-filler system for a while, but this is more for HDRP settings. So as you move between volumes, you can blend between these settings. And some of the settings that you can blend are, you know, like the volumetrics, like do I want fog, do I not want fog, do I want my shadows from the sun to draw far into the distance, or do I want to shorten that to save some performance on sun shadows? It could be you're entering a cave and you want to maybe drop your cascade down to a very bare minimum until you reach the exit of the cave, where you can slowly blend them in again, for example. So these are both for optimizing performance, but also just for adjusting for different kinds of contextual needs in your levels. If your contact shadows in a particular space of your world is being a bit then you can, you know, go in and fiddle with that locally. Volumetrics kind of tie a little bit into the volumes, because you have per volume control over the volumetrics, but you also can paint out volumetrics in terms of actual like tiny volumes in the level. So, and these volumes can be loaded with 3D textures, etc. So you can make little clouds. You can also fade them on, like you would fade the maybe the sides of a reflection probe or something like that. So in here, you can see volumetrics from up here. And it's a bit noisy in the scene view, but that's because this effect is temporally filtered frame by frame to become smooth in play mode. So if we Maybe I should go to game view. This went well. Let's kill Unity. This seems to be my curse, like my mega city hung on stage at the keynote yesterday. That was a lovely moment. Wrong editor. I have a shot here. So this is with volumetrics on and off. So you can see I get nice beams out of this sci-fi ventilation lava unit on the wall. And the blades are actually rotating in real time, so you get like these streaks coming out of it as it's moving in game. And you can see that the fog volume at the back of this corridor has like a slight cloudy texture. That's a 3D texture that you can tile and animate through the volume and things like that. And as I said, you can grab each plane of the box and fade the volumetrics in and out. Then we have decals, big thing for environment artists in Unity. So we have projector decals and mesh decals. So you can now both basically model decal trims into your geometry or project decals onto the geometry. The mesh decals take a slight performance hit. You need to enable the basically a decal buffer, which uses a little bit more memory. But it's an opt-in, like everything in HDRP. Pretty much every feature is an opt-in or opt-out, depending on what kind of performance you need out of it. But yeah, so we have projected decals and, like I said, mesh decals that you can model basically into your objects. Like at least on Hitman, we use that insanely heavily. Like everything had decal trims. Like the corner of this podium would have basically a baked trim all the way around the corner, just running around, and then we would use tiling materials on everything else. So it's really, really powerful environment authoring tool to be able to do mesh decals. We did not have the feature when we built most of the assets for this sample game, so they are not heavily in use, but in future projects they will definitely be. I never finished the refraction and distortion slide, so because I intended to load it real time here, but we have the actually open with a slide where I can talk about it. So this is rendered in HDRP, and you can see that the glass on this sort of terraforming pod is slightly translucent, and you can see the light coming through the honeycomb from the backside, and you can also see the backside of the honeycomb at the top is slightly blurred as you're looking through the glass. So there's both refraction and distortion going on here, and there are two modes of refraction that are enabled in HDRP that you can toggle on the shader. So one is for planar surfaces, and the other is for surfaces that are more spherical in nature, right? So these are two abstraction levels because it's not perfect ray-traced refraction, right? It's an imitation. So you can do one for planar, which you can use for like frosted glass windows and stuff like that, or one for sphericals, which is what's in use here. And then you can load up a vector map, it's called, but it's basically just a normal map with red and green channel representing the normals and the blue channel representing the amount of blur that you want to get through the medium. And then you can also control like the depth travel, how far should light travel inside this medium as well to create this green watery effect that I have here. For lighting the sample game, we're running a distance shadow mask with baked indirect. We try to do physically based lighting units, whatever that means in space, and we light dynamic objects with light probe groups. So what this means in practicality is that we have shadow masks for all our mixed mode lights, so that's the sun and any big sort of light unit within the level. They bake out into a mask in the light map, and they can only influence the pixels that are inside that mask. So the cool part about this is that we can then take this distance shadow mask, and as we move away from the light source, we can stop doing real-time shadows and blend into a baked shadow mask at the distance. This is great because this gives us a slider that we can move depending on the hardware that's running the game, right? So you can do practically zero distance dynamic shadows, and you'll just have a kind of low resi shadow bake for the whole game and no dynamic shadows, or you can move it 50 meters out and then you have real-time dynamic shadows, you see foliage moving in the shadow map, etc., and then beyond that distance you just fade to this quite low-res shadow mask. And then the baked indirect is in there together with the shadow mask, so you have color bounds from objects and stuff like that, which don't need a lot of resolution either. So you have kind of a very low-res light bake for the entire level that gives you most of the beneficial parts you would want from a light map bake, while still maintaining dynamic shadows. And then on top of that, so we only do this to save basically a light map space. We only do this for like our ground, our bigger rocks, our interiors, and then every detail problem on that, like pipes and foliage and stuff like that, they just receive lighting from light probe groups. There's some stuff there. If you download it, kind of a repetition of what I just said. But shadow masks ensure that lights don't leak through walls and things like that because they only influence the pixels that are actually baked into the shadow mask. And the occlusion probes make sure that the dynamic objects don't receive either because they have a baked-in occlusion on that particular light source. Yes. So the vast majority of our light probes, if you've used Unity and you're a lighting artist, you're probably immensely fond of placing light probes, I can imagine. But the vast majority of our light probes are actually inside our prefabs and our prefab variants. So when we have the tile set to build the interior elements of the level, we just have a light probe group in every prefab and then populate light probes on the surface of that particular prefab, and then that all gets collated into one light probe system in the level, so we don't have to go and spam them out everywhere. In the level, we just have to place them coarsely in the air, right? So everything is covered on the surface level with light probes from the prefabs, and then we just spread a coarse grid inside the level where in the open spaces, so basically in the vacuum of the level. Since we're running HDR lighting and we have very high contrast lighting between the sun and the interior, like the sun is many orders of magnitudes brighter than the lights that are inside, you need quite a lot of probes to be able to handle basically the transition in different ambience levels. Like if you have the sun coming in and you get this sharp border into a dark interior, you need enough probes that your character is going to pick up a good spot when he's right in that transitional area between the sun and the dark ambient inside. So we have quite dense light probes, and that's luckily easy to do because they auto-populate based on our prefabs. We are definitely looking into better tools for placing light probes, though. So here we see the bright sun outside. It's quite bright, and we get some nice indirect bake into the interior from that open doorway. We are using lux lighting units now in HDRP, so you can relate to real-world light sources by typing in a lux value that is appropriate for the kind of light that you have. However, real-life sun intensities still provide more contrast than is typically maintainable in a game. And I mean this more in the sense of, in the real world, like I can barely see what's outside that door because it's so bright out there, right? That's not necessarily fun. It certainly wasn't fun on Hitman to be constantly spotted by NPCs that you couldn't see outside. So there are some limitations if you're doing a game about, like, if you just use naive sun intensities, you will also get all the issues that the real world carries, and that might not make gameplay entirely fun. So on the sample game, so we're not fighting across these doorways and not being able to see each other. We run 2000 for the sun, and that gives us the opportunity to do a nice bloomy feel, but you can still see the spaceship outside and, you know, pick up contours and contrast and things like that. There is also another issue with super high light intensities, and that is that reflection probes can tend to pick up even as 1 pixel mistake of the sun, and then you get like fireflies everywhere inside, right? Because we're not, the reflection probe is an approximation, and the content is an approximation, and, you know, everything is a little wobbly in 3D. So you can, if you do full 100,000 lux for the sun, tend to get these fireflies that just propagate through all your content because of specular reflections from reflection probes that are not entirely correct. So 2000 seemed like a compromise between us still getting, you know, nice, sharp specular highlights on the content and being able to adapt so that we could have gameplay that transitioned between interiors and exteriors. We have some custom solutions. You could call them hacks. So for LODs and light maps, in Unity right now, if you mark all your LODs as light map static, it'll literally have to spawn, when it's doing all the raycasting to light mapping, it'll have to spawn the world every time a lot changes. So for each lot, it'll have to set the rest of the world to lot 0, so regenerate an entire sort of system for the light mapper to do that, and then troll through all the dots. That's not performant at all, and it causes your light map bake times to go completely out the window. So like, wouldn't finish in a month if we did it that way. So what we do is we have a script that takes the light map from the lot 0. So we only have lot 0 to be light map static, and then we steal the light maps with a script from lot 0 on the secondary and tertiary and so forth. So we just bake the whole world as lot 0, and then the LOD meshes steal the light map that they need. This of course means that your LOD meshes need to have matching light map UVs with your lot 0 for it to work. So that's an authoring restriction there. But once you do that, everything bakes quite fast, and I fully expect when the GPU light mapper is completely on the road to be able to bake this entire level in around 30 minutes. So it shouldn't be too bad. And we have progressive baking in the new light mapper, so you can look at an area and just bake that part. Another hack we have is for LPPV management. So I'm just name dropping an acronym here that people may or may not know. But light probe propagation volumes are a way to blend light probes together. So they are a 3D texture representation of a bespoke light probe space. In actuality, this means that light probes are great for lighting individual objects, like a plant that's standing there on the terrain, but they're not great at lighting interconnected objects because each object picks like five light probes and calculates the influence. That means if you have like a tiling segment of pipes that are each picking their own sets of light probes, you will have sort of dramatically different lighting per pipe, enough that you notice like, okay, that one has that ambient lighting, that one has that ambient lighting, and they're not at all blending together. So what we do is we basically bundle all the things that we want to share this LPPV volume up, and then we auto-assign them to that LPPV. So we have a small tool for that. So if you go back home and get the project from GitHub, that's what these LPPV folders are. They have a script on them that says everything inside here should be assigned to this LPPV volume. So it picks up, for example, all the pipes in a big room and makes sure that they get blended indirect lighting instead of individual indirect lighting. And then we have a hack for the main shader in HDRP, which is for adjusting the FOV of the weapon. So if you've ever done a first-person shooter, there's a bunch of compromises you have to do with the weapon, depending on what game you're making. If you render it naively in the same FOV as the world, your weapon has to be the correct world size. And then you're forced into a situation where you have to render it in a different path so that it doesn't go sticking into walls when you walk up to a wall, etc., right? Because it's literally a meter in front of you, and you certainly don't want to do collision in an FPS 1 meter ahead of you because that feels really weird. Then you can't go through a door sideways with the weapon out and things like that, right? So that's a problem. So for that, some FPSs, they render in a different path so they can control the depth and not have it intersect. That leaves you with other problems that we could talk on for hours, but But that's one solution that is used out there. What we decided on was to make the weapon really tiny and render it in a different FOV than the main world. So we could make it tiny and then bring it up in scale by having the field of view being adjusted in the shader. So this has the benefit that now we don't need a separate pass to render the weapon, which is way more performant. And let's try and drop in there so I can actually demo it a little bit, because it's a little weird until you see it. And the benefit of that is that you then support all aspect ratios natively, because as you change the aspect ratio of the screen, the FOV of your gun stays solid, right? So you don't get this thing where your gun is like stretching across 3 screens because it's rendering in a 180-degree FOV, which would be really ugly. So with this, now the weapon is rendering in a different FOV than the screen. It stays in the same perspective, right? No matter how I look, which would be really nice if you were on a widescreen monitor, like an ultra-wide monitor. They're getting fairly popular, or you have a 3-screen setup because you're nuts. Then that'll work. Like if we didn't have this, then literally the end of the gun would be sticking all the way to the corner of the screen right now, and that would look super bad. So there are different problems and wins and what have you with this. I noticed in Doom they do this, and then whenever you have to interact with the world, his hands go down, and another set of T-Rex hands comes up that are drawn in the correct FOV, and then grab the handle really quick and then hide again, right? So if you do ultra-wide in Doom, you see these kind of things where you have to mix and match. Because if you have to interact with the world, you have to be in the same FOV as the world, right? And then you have to have a different set of hands at a different FOV. It's quite weird. But there are really no beautiful solutions to FPS weapons that I know of, at least. But if you have cool ideas, by all means. Then we have material overrides, which is essentially our implementation of material instancing. Peter spoke a bit to it quickly in the keynote last night, but it's just a system for us to define for a given material a set of overrides and then be able to apply those individually onto objects in the scene, either with an asset that we store in the project or just doing it sort of individually on each object. So that's just some tooling that we made because it's weird that we don't have material instances in Unity, but hopefully this will make its way into Unity as a default component, but for now this is what we're doing. I'm really good at this. Yeah, so this I already spoke to. This is a material instance override in action, right? So it's just literally changing the color of a pipe, and that's what it does. And when you apply it, you can apply it in the hierarchy. So you can apply it at the top of something, and you can click populate from children and find all the materials in that hierarchy, and you can do overrides to them, right? So if you have multiple materials on a car, for example, and you want to change the color of all of them to make a blue car, that would be probably a nice use of this. And it lists the affected renderers here, right? So it's affecting both lot 0 and lot 1, as you can see, and that's auto-populated. It's using material property blocks behind the scene, right? So and we have confirmed with the rendering teams that this is the expected way to do material instancing in Unity going forward, and probably, or most likely, will be the way that we do it with a default component in the future. So the future of the FPS game, 45 seconds left. So our goal for the future is to cert this on leading console platforms. So we want to get it running on PS4 and Xbox, and we actually want to run it through the full certing process with Sony and Microsoft, so you guys can be confident that if you take the usage pattern, if you take the menu patterns, etc. from this game, you will have a smoother ride through cert on those platforms. We know that our UI is poopy and bare bones and stuff like that, but we just haven't had time to become good UI artists. We will continually update the content with new Unity features and changes to workflows. And a side note at the last end is like, oh wow, the VFX are so shitty, and you are not wrong. So HDRP out of the box when we were using it did not have backwards compatibility with Shuriken, our old particle system, and VFX editor that was showed at the keynote yesterday was not quite production ready enough that we felt like we could have the content ready for you today. So consider all the particle systems that are in there entirely placeholder. And Tom Ish, the amazing VFX artist that co-authored the new VFX graph, has promised you'll make us some super sweet effects for an upcoming release. So, yep, they're coming. Sorry, they're not there right now. Cool, I have no time left. But that was it for the sample game and the art. I hope there was something a little bit for everyone in there. I tried to cover as many bases as I could possibly in 45 minutes, but there's a whole world in there ready for you to explore and figure out how we did things, right? So, in the editor, steal everything you want, sell it on Steam or whatever people do these days, you know. Flip it, we don't care, as long as you have fun with it. Great.